Hello, this is Dan Alford with ARC Specialties. We're known for the exotic welding processes like laser or plasma and hot wire TIG. But today we have a gas metal arc project. Gas metal arc or MIG welding is probably the most common welding automation process used in the world today. But we're showing you this video because sometimes welding is the least significant piece of the production process. Nick Augustine was the project manager and programmer on this project. Nick always exceeds expectations. He added a lot of interesting features. For example, he used a barcode reader to input the part number. From the part number, we know the length, the diameter, and the wall thickness. Once we know the dimensions of the part, we're able to calculate optimal welding parameters, including surface speed. We're also able to calculate what the probable force would be to align the part, because the first step in the process is to straighten the shaft. To explain it, let me describe the entire process. First, the two ends are placed on the thin wall tube and placed into the machine in the load station. There's two stations on this machine, a load and a weld side. That way the operator and the machine don't wait on each other. Once the new part is loaded into the system, the carousel will rotate from the load side to the weld side. The two welding systems will move out. Each one of the welding systems has its own laser displacement transducer. We rotate the part and determine the total indicated runout and the position where the high point exists. Once we've scanned the runout on both ends of the shaft, we determine if it's within tolerance. In this case, we're looking for less than 0.01 or 10,000ths of an inch total indicated runout. Rarely is the part within tolerance after initial assembly. What we've found is rather than pressing the part straight, a kinetic straightening system seemed to work much better. We have found that impact straightening overcomes the internal stiction of the weld joint at a much lower overall force than traditional straightening techniques. As you can see from the video, seldom is this a one-step process. After impact straightening, we again inspect the part, look for the total indicated runout and the position. From this data, we're able to determine where subsequent impact straightening should occur and at what amplitude of force. So this is an iterative process. It'll probably take multiple impact cycles to get the total indicated runout within tolerance. After impact straightening the shaft into tolerance, we're still able to improve on the total indicated runout. As everybody knows, welding causes distortion. By selecting where we should start the weld, we're actually able to remove a bit of that last remaining total indicated runout and make the shaft even better and straighter than when we started to weld it. As you've just seen, the most challenging part of this project was not the welding, but the straightening of the shaft prior to welding. After we impact straighten the shaft and determine the optimal weld start point on the shaft, it's relatively straightforward to gas metal arc weld both ends of the shaft simultaneously. I think Nick did a great job on this project. By incorporating not only the welding but the straightening into a single machine, he allowed the customer to have a much more efficient overall operation. This is what I'm seeing all over the world. As everything gets to be more competitive, our machines have to become more efficient. At ARC Specialties, we thrive on problems. Send us yours.